Hi, alright, this is the problem that is about rate of change, okay? It's under the application of differentiation. So, and this question is telling, if you have my lecture notes, you can get the lecture notes from me. And this lecture note, this question is saying that water is poured into a container having the shape of an inverted cone. This is called the inverted cone, right? Inverted cone, terbalik, alright, inverted cone. So water is poured into, okay, the water is poured into the inverted cone at the rate. So it means that the water, as you said, that water is represented by volume, right? As you keep pouring inside there. So it's about dV dt. It's a positive value because you keep pouring inside, there are no leaking. If you keep pouring, the water level will be increased, right? So, and at the rate of 30 centimeter cube per second, alright? Centimeter cube per second. If the radius of the base of the cone means that this cone, of course, is a fixed one, it's a container, right? So, and it will be 12 cm, okay? This is a fixed one, and the height of the cone also will be fixed. So, and the height is 18 cm. And you know that the height of the container of the inverted cone is 18 cm and the radius is 12 cm. So find the rate. The question is find the rate of increase of the height of the water level. So it means that as you pouring, there is a water, right? There is a water inside the cone, right? And this water have its radius, and the radius is changed with time, right? If you keep pouring, the radius will increase, and the height of the depth of the water in the cone is also increased. So the question requires you to find the rate of increase of the height of the water level. So they require to find dH dt, the rate of increase of the water level. When the height of the water level, is 4 cm. This is all the information given. So this is a problem solving question. So you have to solve the problem, okay? And they're giving you an inverted cone where you keep pouring the water, alright? You're pouring the water into the cone. So as you keep pouring, the water will increase, the radius increase, the height also increase, right? So, and find the dH dt, right? So, and this is about the volume and height, right? Now you want to find dH dt given dV dt. So you're going to relate volume with height. Alright. So the volume of the cone of this one, the volume of the water with the height. So then I have to say that the volume of the water is shape of cone. The liquid will follow the shape of the cone, right? So the formula will be 1 over 3 pi r square h, right? This is the formula for cone. Right? But we cannot differentiate V with respect to H, right? As we need to find dVdH because we want to find what? We want to find dH dt, right? So if you want to find dH dt, so you need dV, you can say that dV dt to be dV dH multiplied with dH dt, right? So it's a chain rule. So if you close these two, you will get back dV dt, right? So dV dt is the same as dV dH, dH dt. Or I can say that dH dt is the same as dH over dV multiplied with dV dt, right? These two is chain rule. Either one is okay, right? For this case here. But the problem here, there is a radius here. Radius is not constant. Radius is changing. It's changing, and height also changing. You can't differentiate something which two have changing, right? So you have to replace the R with H or H with R. Because you want to find dH dt, you have to replace the R. Means that you have to find the relationship between R and H. So for cone, there is a very special concept here. We're going to use the concept of triangle here. If I draw from here to here, it's actually a right angle triangle. Can you see that? It's a right angle triangle. So if I draw bigger a bit, this cross section here, this side here, I'm going to see that this is a R. I'm going to use proportional, right? Proportional. So R, the ratio of R to H is the same as the ratio of 12 to 18, right? This concept very important. Or is you learn during your secondary school, so where you learn about the proportion, right? So you can say that 12 divided by R 12 divided by the R. And the height of the bigger cone and the water, 18 over H, they must be proportion. Or I can say R over H. Or I can say R over H. This is a very important concept. R over H is the same as 12 over 18, right? So which is 2, 6, 3, 6, 18. So then I have a relationship between R and H. So which is R equals to 2 over 3 H. This is a very important relationship in order for you to able to differentiate this. So, and I have to replace, okay, I have to replace the V, everything in term of H. So 1 over 3 pi R square H. Your R, you will get from here. So which is 2 over 3 H. And if you write 2 square, you will have 4. 3 square, right? 2 square, 4. 3 square, you have 9. 9, 3, 27. Pi H cube. So this is the volume of the water with that change with H, right? Change with H. So we have already replaced the R with H. So now we're going to consider this one, and we're using this to find our dV dH. So we find dV dH from here. So dV dH, we need dV dH here, right? Or dH dV, we need dV dH. So dV dH is the same as, differentiate this. Pi is a constant, so you're taking out the 3, 4 pi over 27, right? 4 pi over 27, bring down the 3, and the H become power of 2. So then your dV dH, you will have 3, 9, 27, which will be 4 pi H, 4 pi H square over 9. So this is your dV dH. So, and you need to find the value of dV dH when the time H is 4 cm, right? Because you need to find the dH dt when H is 4 cm. So when dV dH, when H is 4 cm, so which can be 4 pi 4 to the power of 2 divided by 9, right? Divided by 9. So you have 4, 4, 16. 16 times 4, you have 64 pi over 9. This is the value of dV dH at H equals to 4 cm. So with this information, with all the information, I have enough information for me to find dH dt. So I can use this or either this one, but I use this one better, right? It's the same, right? So dH dt. So dH dt, you want to find dH dt. Therefore, dH dt is the same as dH dV. This is dV dH. So this one you invert, all right? So you're getting 9 over 64 pi, all right? 9 over 64 pi. Multiply with the dV dt. dV dt is given, right? dV dt is given, is positive 3. So then I have 3, 9, 27, right? 3, 9, 27 per 64 pi. All right, 64 pi. So centimeter per second. Because this is a height, right? The height. So the dimension for height is centimeter per second. All right, that's all for this video. Hope you understand. As the most important thing is for cone, you're going to using this relationship here, this proportion, okay, the concept of triangle, right? And you see how I'm using this and generate the relationship between R and H, and replacing the volume, the formula of the volume with everything in terms of H, or you also can replace everything in terms of R. But for this case, you must replace with H because you need to find the dH dt. So I think that's all for this video.